Hi, today we are going to see about the modes of heat transfer. There are three modes of heat transfer. First one is conduction, second convection, and third is radiation. What is conduction? Conduction is a heat that is transferred from a higher temperature to the lower temperature. So it requires a physical medium which is directly in contact with the substances. That is, the pure conduction takes place between the solid to solid, and also the conduction takes place between liquid to liquid and gas to gas. For our case, for many commonly we consider solid to solid as a pure conduction. In conduction, the energy exchange that takes place, that is due to the vibration, that is lattice vibration. The free electrons in the substance is used to transfer the heat from one end to the another end. The governing equation related to the conduction is Fourier law of conduction. Some of the fewer examples are the transfer of heat in any metal mediums. For example, the heating of vessels, heating of IC engines, furnace, and even the heat losses from the wires, electrical wires. The governing equation for conduction is Fourier law of conduction. It states that the rate of heat transfer or through conduction is directly proportional to the area measured normal to the direction of heat flow and to the temperature gradient in that direction. It is denoted as Q is directly proportional to A dt divided by dx. The proportionality can be removed by the constant minus K. So the final equation is Q is equal to minus A dt divided by dx. K is the thermal conductivity of the material, and this negative sign that indicates the heat flow from higher temperature to the lower temperature. Next, the thermal conductivity. As discussed, this is a material property. It represents how much the heat conducts by the system. It is the material property and defined by watt per meter Kelvin. It depends on the chemical composition of the substances that rise in temperature, and many other things like voids and the chemical and physical properties of the material. The chronicle orders of the higher thermal conductivity to the lower temperature, lower thermal conductivity is as follows. The first one is a metal, another one is the alloys, another one is the non-metallic crystals, then followed by the amorphous solids, then liquids, gases, and insulators. Next one is the convection. Convection is a complex heat transfer mechanism that occurs between the solid and the fluid medium. The fluid medium contains the gases and liquid. Similar to the conduction, convection is also, it takes place due to the temperature differences. Whenever the temperature gradient uh, between the solid and the fluid, the convection takes place. The convection heat transfer, it is due to the interaction between the molecules of a solid and liquid due to bulk modulus transfer of energy. The governing equation related to the convection is Newton law of convection. Example, the heating of pan that actually boils the water inside. Next, the cooling of IC engine and other uh, electrical components such as CPU and transformers and nuclear reactors, etc. The governing equation for convection is Newton law of convection. It states that the rate of heat conduction is directly proportional to the area measured normal to the direction of heat flow and to the temperature difference between the surface in that direction. It is denoted as a Q is equal to HA delta T, that is Ts minus of T. The heat transfer coefficient H is the it is a medium property. It depends on the medium how the process takes place. It is denoted by watt per meter square Kelvin. The thermal conductivity is a material property, whereas this heat transfer coefficient is a medium property. It depends on the time and the different type and the process how the heat transfer takes place. Next one, the radiation. Radiation uh, is neither simple nor the complex. So it is the intermediate process. Actually, that the heat transfer takes place from one body to the another body without the uh, aid of the medium is said to be the radiation. It is an electromagnetic wave phenomena. It doesn't require any medium to transfer the uh, energy. Usually, it is very perfect in vacuums, so that the heat exchange between the sun and the earth it takes place 100 500 seconds, which is 8 minutes and 20 seconds. The governing equation related to the radiation is a Stephen Boltzmann law of radiation. The examples, um, the heat transfer from the light daily source, and heat transfer from any heat zones such as cooking vessels, uh, the solar lamp, and etc. The governing equation, Stephens Boltzmann law, it states that the rate of heat transfer through radiation is directly proportional to the area measured normal to the direction of heat flow and the fourth power of the surface temperature, which is denoted as Q is equal to sigma A T power 4. The sigma is a Stephen Boltzmann constant. It is a constant throughout the process. It is 5.67 into 10 to the power of minus of 8, which are the unit watt per meter square Kelvin power 4. And thank you.